Hello, CS1 students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. And on design example 6, we have 15-page document, and this will be C++ functions video number 7, part 3 of the design example 6. In design example 6, I'm doing only 3 videos. This is the last of the 3. Other details you'll have to get by reading the design example 6 document. Okay, so here I'm going to discuss a function called getRoots. Let's see how we can design the header of the function. This is done in a series of questions and answers. Left column asks the question, right column answers them actually. What is the purpose of the function? Function receives value a, b, and c from the calling block, and calling block makes sure that a is not 0. That's the job of the calling block. When a is not 0, it will be a quadratic equation. Every quadratic equation is going to have 2 roots. That's why it's called quadratic. And we already discussed early on that roots could be real or complex number. Roots are real when discriminant is 0 or higher than 0. It's a complex number when it's less than 0 or negative. So function computes the roots formed by variable a, b, and c and returns the roots to the calling block. Also returned is a Boolean variable that would inform the calling block whether roots are real or imaginary. Okay, what is the decision on the function name? Assume that software group had extensive discussion on naming and decide the name getRoots. What will be returned to the calling block by the return statement, and what is its purpose? A Boolean value is returned to the calling block. This Boolean value is true if roots are real. This Boolean value is false if roots are a complex number. Roots are a complex number if discriminant is negative. Review either early part of this document or lab 3 to know what is discriminant. Which parameters would be populated by function and would be passed back to the calling block by reference? We have 2 of them, root 1 and root 2. When discriminant is 0, root 1 and root 2 are same, this value. If discriminant is, no actually, yeah, when discriminant is 0, only this is returned and this will be 0. When discriminant is greater than 0, okay, so I could be wrong about this. I have to see a little bit later. Okay, but I thought, no, root 1, root 2 will be same for the discriminant being 0 or greater, but it will be different for the imaginary. We're going to figure that out. This is probably not what we mean to say. Okay, we'll figure that out in the analysis very soon. What are the data types of root 1 and root 2? Any arithmetical solution value of value unknown in an equation can never be guaranteed to be a whole number. Okay, so let me say that again. And any arithmetical solution of value of an unknown in an equation can never be guaranteed to be a whole number. That's a fact of life. So therefore Roots will be floating point type. We'll use the double data type for root 1 and root 2. Based on above facts, what is the header of this function? And bool get roots. Int a1, b1, and c1, these are passed by value by the calling block. And root 1 and root 2 are outgoing, passed by reference. So we have done a question and answer session to design the header. Now we go to see what are the function input. So input could be populated variables or just the placeholders. So we have three variables which are same nature, a1, b1, and c1. They are int type and they are all passed by value. They are already determined by user input. Get parameters function actually does that. We discussed get parameter function last time that uses those. And they're not passed by reference. Okay. Because pass by value, we decide pass by value and pass by reference mutually exclusive. So if we are passing by value, we can't pass by reference. Does function needs to declare this variable in the function body? No, because as we look at the header, A1, B1, and C1 are already part of the argument list. Anything that's part of the argument list does not need to be declared in the body. Okay, root 1 and root 2, these are to be populated by the getRoots function. So obviously they are not passed by value. And are they passed back to the calling block using pass by reference? Yes. However, the function populates these variables. Thus incoming arguments act like a placeholder, do not have to have any value. See how that's done in figure 1. And I don't need to declare it because those are part of argument list right here. Root 1 and root 2. Anything that's part of the argument list does not need to be declared. Okay. In this one, function does have output. And output may be outputted to the console, may not be. One of them is real, which is bool type. Bool value is true if root 1 and root 2 are real roots, which means discriminant is greater than or equal to 0. Otherwise, function returns false, discriminant less than 0. Root 1 and root 2 will be outputted to the console. They're both double type. And you'll have real first root for discriminant greater than 0, or real part of the complex number if discriminant is 0. So root 1 is fully determinable if discriminant is greater than 0 or equal to 0. So in that case, it's just like final value. And one of the final value. And root 2 will be either second real root for discriminant greater than or equal to 0, or only the imaginary part of the complex number when it's 0. Note, it is perfectly normal in some cases to include some parameters in both input and output tables to fully understand the nature of a parameter. Okay, so this one has to decide about the discriminant, whether discriminant is greater than 0, equal to 0, or less than 0. This condition or that condition. So that's done by nested if and else. So we have to use the table of Boolean conditions in this case. We didn't need to do that for the get parameters. So in this case, there are two math form or C++ form of discriminant will be this one. So that's the only math part. Other is the this table of Boolean condition that only tests discriminant. If discriminant is equals 0, if that is true, then really both root 1 and root 2 are same, which is given by this expression. Cast to double B1 divided by 2 into A1. And casting is required because these are int, this, and this. And you don't want to throw away the decimal parts, so we have to cast to double type. But if discriminant is greater than 0, then we do have two separate values for root 1 and root 2. In this case, you have the plus in between these two. In this case, you have the minus. Okay, SQRT returns a double type, so I don't need to cast anything in this case. But if discriminant is less than 0, if that is true, that will be the else block if I do else if, then the definition of root 1 and root 2 changes. Root 1 will be, in that case, the real part minus b1 divided by 2a1, except you cast to double type the b1. So answer the question why b is being cast to double type. Explain that to someone. And root 2 will be simply, because discriminant is less than 0, we'll take minus of that and then take the square root of that, because you cannot have a square root of a negative number. So then root 2 in this case is given like that. So you need to clearly do the math and understand why root 1 and root 2 are different expressions in these three cases. If you don't understand that, you have lost this whole lab. But I'm hoping you will understand, because you did exact same thing in the lab 3. So in that sense, there's nothing new here. So understand why we have this equation when discriminant is 0, two equations when discriminant is greater than 1, two equations, different equations for root 1 and root 2 when discriminant is less than 0. Okay, let's go to the algorithm. So I'll set the discriminant equal to b square minus 4ac. That's the C++ form right here. And I have to return from the function based on the requirement I mentioned earlier. This one, a Boolean value must be returned. So I set is real to true. If discriminant is equals 0, then my root 1 and root 2 are same, given by this expression. And I believe I've left out something in the algorithm. Actually, is true already set to true, so I don't have to change that, because that will remain. So I don't have to add anything new. If discriminant is greater than 0, then root 1 is this, and only difference between these two is this minus value. Otherwise, if it's not 0, if not greater than 0, it will be less than 0. I don't need to test for that. So in that case, my root 1 is simply cast to double type b1 divided by 2a1. That's the real part, and then you'll have the imaginary part. And in this case, I just changed this value to update this value to false. And since root 1 and root 2 are passed by reference, didn't have an incoming value, have the outgoing value now, and then I just return is real. Okay, so that's the IOA for getRoots function. Now I'll show you the source code of this. So let's go to the source code portion. Again, a lot of scrolling in this huge document. Excuse me. Yeah, so that was my getRoots algorithm. I'm going to show you how we convert that source code. One, it's int type, so we just set it like this. Bool is real true, bool is real true. Now we do if and else. So if discriminant is greater than 0, equals 0. Source code does not have the word then, So I just test that, and this expression and this expression is identical, except I do have to have semicolon. Answer this question again, why B is being cast to double type. Else if discriminant is greater than 0, then I have exact same equations and expressions right here. And then this got populated, and this got populated. Same thing here, this got populated, this got populated by same value, of course. Otherwise, it's a complex solution for which I don't need to test the discriminant. And in this case, root 1 will be, real part will be this, imaginary part will be that. Answer the question why minus sign is being attached to the discriminant. But now we need to update the value of is real to false. And after that, return is real. And that's the source code for getRoots function. Okay, so on purpose, I'm not providing a CPP file for the source code. I want you to work with this document whose copy you have and type the source code yourself. Of course, in Word document, source code is all here, so it's not going to be that hard for you. But I would prefer that for each function, you understand the IOA and an algorithm, and you actually write the source code yourself, type it and make this function work. I'm not providing CPP file for the same reason. I want you to make it work. And then I have two homework exercises. Read the source code for void print solutions function, print real solutions, and write IOA for it. And read the source code for void print complex solutions and write IOAA for that for practice. So we have completed the second major function, getRoots. It's IOA in this video number 7, I believe. So let's just go back to our, part 3 of design example 6. Rest of the functions, including main functions, you'll have to study from this document. I didn't do IOA for 3 functions, main, print real solutions, and print complex solutions. So as an exercise, homework exercise, you'll have to do that yourself, which will help you to learn this more. Okay, so this is Dr. Singhal saying goodbye from C++ Functions video 7, last part of the design example 6, and I have future videos in the functions which were done in past. They will be just added to your class and you can watch those. Thank you.